Okay, this is a video that's going to quickly go over the questions in the simple harmonic motion topic test. So, starting with question 1, this is about the bouncer. Jamie has a baby cousin whom he looks after for his aunt. He puts her in a bouncy net, which is a bouncy lion seat as shown. Jamie notices that the high end of the bouncer deflects downwards by 15 centimeters when the baby is placed in it. So this is going to be Y. The bouncy net can be thought of as a spring, so we'll have a spring constant which can be calculated. The cousin has a mass of 6.5 kgs, that's an M. Okay, so calculate the bouncy net spring constant. Write your answer with the correct unit. Okay, so Y is going to be equal to 0.15 meters. Everything needs to be in SI units. Quite a few of you made the mistake of leaving that in centimeters. And F, the weight force, is going to be equal to 6.5 times 9.8, which is equal to, let's find out what that is. So 6.5 times 9.8 equals 63.7. So that's 63.7 newtons. And we know that for a spring, F is equal to negative K Y, which is equal to, so therefore K is equal to F over Y. And if we consider the force to be downwards, if we consider the displacement to be downwards and the force that the bouncy net produces is upwards, so we'll say that this Y is the negative one. So we can say negative K is equal to F over Y, which is equal to 63.7 divided by negative 0.15. And so that will give us 63.7 divided by 0.15 equals 425. Sorry, that's negative 425 newtons per meter. So K, so then remember that was negative K, so K is equal to 425 newtons per meter. If you didn't do this negative thing and you ended up at 425 newtons per meter, that's fine. If you used 10, I also didn't mark you down. But that's the process. The most common reason for people losing marks was not converting this to meters. Okay, the second question says, as the baby moves, she causes the bouncy net to oscillate up and down. Over small angles, it's simple harmonic motion. Define simple harmonic motion. So there are 2 points that we need to make. The first point is that it's displacement and acceleration are proportional. And secondly, and in opposite directions. Okay, calculate the period of the bouncy nets of the baby's oscillatory motion. So 425 was the spring constant, 6.5 was the mass. So we use the fact that T is equal to 2 pi square root m over k, which in this case is equal to 2 pi times the square root of 6.5 over 425, which is equal to 2 times, where is pi? There. Pi times And then we have 6.5. Hold on, I need some brackets in here, so let me just fix that. 2 times pi times, I need an open bracket there, open bracket, and then we have 6.5 divided by 425, close bracket, square root is equal to 0.78, 0.777, 0.78 seconds. Calculate the angular frequency omega of the baby's motion. Omega is equal to 2 pi f, which is equal to 2 pi over the time period, which is equal to 2 pi over 0.77. So that's 2 times pi divided by 0.78. And I'm rounding a bit here, which isn't great, but I think it's not going to make a difference because it's accurate enough. So it's 8.1. Sorry, that was 0.78. So that's 8.1 angular frequency, so it's radians per second. Okay, we will write that in here. 8.1 radians per second. Okay, Jamie pushes the bouncing net down with the baby in it and releases it. Calculate the maximum acceleration the baby experiences if Jamie pushes the bouncing net down that distance. So A is equal to A max is equal to A omega squared, which is that first little part that's attached to the trig function for the acceleration, because the trig function only varies between 1 and -1. So A omega squared is going to be 0.075, which is the amplitude in meters, times omega squared. Omega we just calculated and it was 8.1. 8.1 squared. So this is 0.0075 times 8.1 squared. Where do I have my square function? There it is. Equals 0.49. 0.49. And that's an acceleration, so that's meters per second squared. Explain what happens to the period if Jamie puts his 13 kg cousin into the bouncy net instead and include the new period. So mass will increase, double. Period is proportional to the square root of the mass. And we can say as t is equal to 2 pi square root m over k. So if m doubles, period will increase by a factor of square root 2, i.e. new period will be what was the old period? It was 0.78. So new period will be square root 2 times 0.78, which is 1.1. Okay. Alternatively, you could have just plugged in the new value for the mass here, kept the same spring constant. You would have got the same answer. Okay, so that may be enough to get you full marks. This is an excellent question. However, you should really explain why that's the case as well. So, for a given displacement, the spring will exert the same force on both masses. However, this force will cause the larger mass. Oh, sorry, I'll word that slightly differently. Let me just erase that. Will cause a larger acceleration for the smaller mass. Thus, the period will be shorter for the smaller mass. Okay, so now I think we've covered all our bases with that question. We've both shown it in terms of the equation, and then we've given a little explanation relating it to the acceleration. Okay, part G, and this was using the reference circle, and this is something that just it takes a bit of practice to get the hang of. Many of you left this one blank because maybe you hadn't had a chance to study it, but it's worth studying it. It will always come up, and once you have mastered it, it should be kind of easy marks. And so we want to know how long it takes to go from position A here to position B here. And so what we want to do is draw the phasor here. We're interested in how long it takes, oops, a pen won't write there. How long it takes to go from this position to this position. And so the angle that we want, the total angle that we want, is really this angle. And to get it, we really want to use one of the right triangles and double it. So we can draw a right triangle here. And this angle we can work out. This side here is 7.5. And this short side here is 3.75. So we can work out what theta is and then double it, and that will give us the angle that the phasor is swept through, and then figure out the proportion of 360 that is, and it should be the same proportion of the time period. Okay, so let's do that. So the first step here is to find theta. Theta is going to be equal to, what's the opposite on the hypotenuse? So it's going to be the inverse sine of the opposite over the hypotenuse, which is 3.75 over 7.5. And we can work in degrees or in radians, it doesn't matter here, as long as we're consistent. So we go open bracket 3.75 divided by 7.5 0.5, close bracket, and then we want the inverse sine, and that gives us 30 degrees. Oops. Okay, and a angle phasor has swept through as bouncy net goes from A to B is 2 times theta. Which is equal to 60 degrees. And then we can say 60 degrees. Well, 60 degrees is 1/6 of 360, so we don't even need to do a calculation, but we could do 60 degrees over 360 should be equal to t over the time period, which we were given up here. The time period was 0.78, right? So t over 0.78. So t is going to be equal to 0.78 times 60 over 360. So let's do that. So 0.78 times 60 divided by 360 gives us 0.13. 0.13 seconds is how long it takes. Okay, so that's the end of the first question. I'll do the second question in a separate video.